In the previous video, we looked at input and output redirection. And in this video, I want to talk about piping. So when we run a bash command such as cat, and then we're going to read from standard input like we've done before, we can set up a pipe with the vertical bar, and we can pipe this to, say, a program like grep, which will read whatever it's sent as input, and any line that matches the pattern that we give it, like let's say we're searching for any line with an E in it, it will print that line back out to us. If a line doesn't have an E in it, it will not print that line. So we can try this out with a word, a line like hello, and we see that grep prints that back out to us on its standard output. And we see that it's even doing something clever to highlight the match. And if we were to try a line such as input, we see that it's not printed back out to us because this line does not contain an E. And lastly, if I were to try something like computer, of course, it has the E at the end, and it prints back out to us. And so we are feeding the output of the cat program into the input of the grep program somehow. And we should talk about how does this come together. And the good news is, based on where we left off in the previous video, we've got a good starting point for thinking about this, right? So just to begin, without thinking about this piping, the way when we run cat with the dash, as a reminder, all of our standard streams are connected to our terminal, right? But when we pipe the output of run program into the input of another, something else must happen in order to make this connection. So when bash is given this command, it sets up a pipe. It asks the operating system to set up a pipe. So just like the operating system has things connected to it like our terminal or our disk, and it's responsible for managing those things, it's also going to be responsible for managing pipes. So I'm going to draw a pipe that we've just now created that bash would create for us when we run a piped command. And I'll draw it like a Super Mario pipe. It has a write end and a read end. And what a pipe is really is just a buffer to write some data to and be able to read it from in order and such that the data goes away once you've read it. Right? And we're going to create some entries in our operating system's IO table to keep track of this. Right? So we're going to say there's a pipe entry, and pipe 0 is going to have a write end. Right? So I'm going to say pipe 0 for write, and I'll say that there's a write entry here. Right? And so there will be one entry for writing to this pipe that gets data into it, and there will be another entry for reading data from it. And so having two entries here, we'll see winds up being something clever that we'll see how this comes together as we think about, well, what happens in the processes, right? But at the operating system level, in its global table, we've got a pipe, and the operating system has some constructs behind it for keeping track of what pipes it's managing, things like that, right? But fundamentally, a pipe is just a place where we can write some data to and read back from it once, okay? So when this command is given, there are actually two processes set up. So there's another process here that's going to have its own process FD table. And we'll explore how processes come to life in a future example. But somehow, by some way, the bash shell is asking the operating system to set up two processes to execute this command. And this process, just like every other process, is going to have its own file descriptor table, where by default we'll have three entries in it. And it will have standard in, standard out, and standard error. Remember, we're just labeling these to make it easier to remember what 0, 1, and 2 refer to. And by default, these might all be connected to our terminal, right? But for this piping to work, so the reading would come from the terminal, and then the writing would go to it in both directions. Right? I'm actually going to leave these arrows off to try and keep this a little bit cleaner for the time being, because we're about to rethink how these things are connected to one another. Okay, so if we are reading from standard input in our cat program, then sure enough, our terminal is going to be connected to the standard input of cat, right? Now this pipe is saying, I want to redirect my output to the standard input of this grep program. But there's not a way of making a connection like this. Right? These processes need to be separate from one another. In fact, a process thinks it's effectively the only process on a machine through a grand illusion of the operating system. But it does know that the operating system exists, and we can make requests to the operating system. And so what it's going to do is it's going to say, well, I'm going to send my standard output to this pipe. Right? And so its standard output is going to be connected to the pipe's right end. Right? So the pipe's right end is going to be what the standard output of our cat process will be connected to. All right, that's great. We're going to be sending our data to the right end. And then standard error, well, we're not redirecting standard error in any way. A pipe is only going to redirect standard output. So it's also going to be connected to our terminal's output. I'm going to leave this arrow off for now, but trust me that if there were an error in the cat program, which we could demonstrate in just a little bit, that it would get redirected, or that it would be sent to our terminal so that we would see it show up, even if we were piping the output to grep. Okay, so now grep is getting its input from cat, right? We wanted this to work such that the output was connected to the input, but we have to go through the operating system's I/O table in order for this to work, right? These connections are made, the processes file descriptors are connected to the operating system's table of descriptors. And so standard in is going to be connected to the pipe that we set up's read end, right? So the read end is going to be connected to the grep program's standard input. And then the standard output of grep, well, we're not doing anything with it. We're not redirecting it. We're not piping it anywhere. It's going to be connected to terminal 0, right? So that's what's going to cause its output to go to terminal 0, right? Or to our terminal window. And same with standard error. I'm going to leave those off as we traverse this connection here, right? So notice the process is when we typed in the word hello, we were typing that into our terminal, right? And our cat program was waiting to read the next line from our terminal because that's what its standard input is connected to. As soon as it got a line, the cat program is responsible for just printing that line back out. And we had connected through this pipe its standard output to the right end of a pipe, right? So it was writing to this pipe. And so that first line, hello, was written into this buffer, right? And then what happened was, well, our grep process was waiting in the background. It's like saying, hey, as soon as there's some data in this pipe for me to read, let me add it. Let me read that data from the pipe. And so as soon as that data had filled the pipe, the grep process then reads from it, and it is taking in the line of input, which was hello, and it's asking whether or not it satisfies this regular expression pattern, which in this case, whether or not it just has an E in it. And if it did, it would print that out to standard out, which was connected to our terminal. Right? And so this is what brought the data back to our terminal. And so now we've got two processes running, and notice how they're connected via this pipe. And so this is what the idea of a pipe is at a high level in the operating system. Now you might be wondering, well, could we redirect input to cat? So rather than typing into standard input, could we do that? Or could we redirect standard output from grep? And yes, these ideas compose in a pretty beautiful way. You can, just like we saw in the previous video, we could set up redirections and they would apply to the specific process we were thinking about. Right? So what I want to point out is a really beautiful abstraction achieved through an idea called indirection, is this idea that when we are calling functions in our programs, such as writing to some file descriptor or reading from some file descriptor, notice we would be giving integers in these cases, and the given process is going to have access to its table. And what's really clever and beautiful about this design is that because those descriptors at the process level are things that we can actually connect up and reconnect in different ways to where it's going to go in the operating system. And we're doing that as we control the programs when we start them in our shell. We can get a lot of flexibility in terms of being able to see output from a program on our screen or send it to a file, or in this case, we can send it to another program even as its input. And it's all through this clever idea that from the process's perspective, all it needs to care about are which of these file descriptors it's reading to or writing from, right? Am I reading from my standard input, my standard output? Okay, that's great. And under the hood, we can, outside of the program or from a scope that the program doesn't even need to know about or worry about, we can decide what those file descriptors are connected up to. So it might be files, it might be pipes, it might be a terminal, right? This is a really powerful concept that is a really beautiful example of a layer of abstraction, right? Our abstraction is we're going to treat everything the same in terms of reading and writing, input and output. And in Unix, we call all of these things, we call devices and pipes, we think of everything as a file because we're actually creating all these entries in the operating system's file descriptor table. But thinking of everything as a file is really, I think that can be confusing the first time you hear it because we think of files as things that are always going to be stored on a hard drive, or at least I often had that connotation of what a file was. But what you should really think of this as is a generic input-output stream, right? And we can connect to these streams in clever ways, and we have complete control over the ways we connect these things together, thanks to things like the shell and what we're going to see soon, some of the underlying functions in an operating system that give us access to these capabilities as programmers, right? But fundamentally, what we're doing from a shell is we've got a really nice little language for controlling these ideas and for connecting these programs up in various ways.